Hello, welcome to the Hodges Effect, the mysterious agency of space grit and tiny scraps of metal. My name is Valerie Byrne and I'm the director of the National Sculpture Factory here in Cork City, Ireland, which you can see behind me on the screen. The Hodges Effect is a project conceived by artist Sean Miller, USA, and Sean Taylor, Ireland, in collaboration with designer Connie Hwang, US. The project is supported by the National Sculpture Factory and Blackrock Castle Observatory, both in Cork, Ireland, as well as the University of Alabama, USA, and the University of Florida, USA. And it's presented as part of the celebration of World Space Week, October 4th to 11th. And it's a huge honor for us to be here this evening to host such a stellar lineup of speakers. And we're very much looking forward to hearing some fascinating and thought-provoking presentations over the course of the next 90 minutes. Our speakers actually join us from 3 different time zones today. So it's currently 7 p.m. in Ireland, and I believe it's 1 p.m. in Alabama and 2 p.m. in Florida. In recognition of World Space Week, this project brings together an international team of artists and scientists to consider and celebrate the significance of Ann Hodges and to begin a campaign to lobby the United Nations for an International Meteorite Awareness Day for Ann Hodges. The project comprises a series of billboards, public art science lectures, performances, and letter writing activism in Ireland, the UK, and the USA. And we're currently delighted to have a series of billboards heralding the project installed across Cork City. So the National Sculpture Factory is absolutely delighted to be part of this project. And I have to say, keeping it very brief, all the discussions that we've had as a group and as a team throughout the darkest days of lockdown were certainly a source of joy and humor and information for us here at the Sculpture Factory. So we are a national resource organization for professional artists. We provide space for artists to make work, and we run a comprehensive program of events, projects, commissions, and workshops. And we're delighted to support this project and to welcome you all. So just a little bit of housekeeping about how the event will run today. We'd ask you to please keep your mics off, and you can address questions into the chat function. Questions can be submitted at any time, but I'll actually wait until all of the speakers have made their presentations before reading out some of the questions. So if possible, please make a note of who your question is addressed to. Each speaker will present for either 5 or 10 minutes, and I'm afraid I'm going to have to be pretty strict with them in order to keep the event on schedule. So without any further ado, it's my great honor to introduce our first speaker this evening, Sean Miller, Associate Professor of Sculpture at the University of Florida. Sean merges the roles of artist, curator, and collector. His work employs collaborative practices, collective approaches, and experimental exhibition formats. Sean's work responds to ontology, materiality, politics, ecology, and institutional critique, and he has exhibited extensively internationally in museums and galleries, and his work often incorporates the notion of the cabinet of wonders, which is a little bit like what tonight's event is going to be. So without any further ado, over to you, Sean. Thank you.
Thank you, Valerie, and thank you to the National Sculpture Factory and the Blackrock Castle Observatory, University of Alabama, and University of Florida for helping get this project going. I'm coming to you today with Jade Dellinger, who is one of the speakers. We're sharing the computer, and we're at the Bob Rauschenberg Gallery in Fort Myers, Florida. And it was a gallery that was originally set up by Robert Rauschenberg as kind of a place to work, show his work and also support the arts, and was very much interested in arts and science. And Jade's going to be talking about later Bob Rauschenberg, and we have theories that possibly Bob Rauschenberg might have been somewhat silently dealing with the Hodges effect. And let's see. Trying to share the screen here. Oh, sorry. I'm only getting Jade's. Hold on a second. I'm only getting Jade's. there. Got it. There it is. Okay, so this project, obviously we're trying to create a campaign for international meteorite awareness. And just to define the Hodges effect, it's described as physical changes and or an existential crisis of being that may occur after a sudden collision between a Homo sapien subject and extraterrestrial materials. The Hodges effect is an emerging concept in the domain of Homo sapien encounters and responses to environmental change. And although a Hodges-style experience may at first be debilitating and disorienting for Homo sapiens subject, it is hypothesized that long-term side effects may prove extremely positive and beneficial. Individuals grappling with Hodges effect symptoms may experience initial angst, disorientation, and agitation. In many cases, however, the after effects seem to imbue individuals with a greater spatial awareness, an increased sense of interconnectedness with the cosmos, and a more complex and informed understanding of the material world. On November 30th, we'll be launching a field guide for hurtling through space, which deals with the intricacies and complexities of the Hodges effect. And Connie Hwang is going to talk about that in a few minutes. But to start it off, this is what we're talking about. This is the actual Hodges meteorite. We've cast a number of them and included space dust in the mix so that we have replicas to help induce Hodges effect within the different populaces that we're dealing with across the time zones. So participants have these and can perform with them. The Black Rock Castle Observatory was kind enough to give us a view of what the sky looked like over Ann Hodges the moment that she was hit. Even though it was during the day and obviously these stars couldn't be seen, this is what the sky would have looked like above Ann Hodges in Alabama when she was struck on November 30th in 1954, when the 7 by 5 by 5 inch meteorite crashed through her ceiling, bounced off her Philco radio, and struck her as she lay sleeping in her Alabama home. It was not long after this that radios everywhere began spreading the news about the meteorite and Ann Hodges. And this is an artist's interpretation of the complex relationship between Hodges, the meteorite, and the radios that were broadcasting and talking about her work. This is the actual, or her fate, I should say. This is the actual Philco radio that was hit by the meteorite before it struck Ann Hodges. And if you'll note the top, you can see the dent where it struck. And this I was able to photograph when I went to University of Alabama with the help of the researchers there who were very helpful. Within a day or so, Ann Hodges began getting berated with letters and emails, or not emails, letters and telegrams in this case. And so she was basically being told to, what to do with the meteorite while she was in this traumatized state after being hit and bruised by the meteorite. In this case, a person was asking her just a few days later to recount exactly what happened for the magazine. People were trying to buy and sell meteorites with her, and it turned into quite a publicity fiasco around her, which was not very helpful. In a way, it's the bad side of the Hodges effect. The meteorite might have been too big. It might have had too big of an impact on her and her situation, being the only human that's ever knowingly we know of that survived a meteor impact of that size or a meteor impact at all. So a lot of the times people were asking, also she was selling pictures of the meteorite as a way to kind of deflect people that wanted to get involved with it. And this is an idea of the meteorite kind of spreading. And in Florida and Alabama and Texas being centers of the space, in Florida we have the Space Coast, and throughout in Houston and all Alabama, Huntsville, where I was born, all these places were in the 60s were really hotbeds of Hodges effect responses because of so many astronauts and people working with these ideas. So, and Hodges effect in the end, since it causes kind of more of a cosmic awareness, we feel that it's something that needs to be safely induced into the public so that we can move on. Like one day we knew this this would fall on us is the message that we're sending to Cork City. And it's okay to experience the Hodges effect if it happens to you. There's a number of different safe ways you can do to approach this problem. This is one of the test things we're working on is these Hodges effect hats, where you can just, if you can get a hold of a little bit of a meteorite, you can have your own, you can get hit by a meteorite on your own and have it be like not as big of an impact as what Ann Hodges went through. So it's kind of like a morphine drip where you can kind of control the amount of the Hodges effect as it moves through you. And so here's, Sean Taylor and I have discussed this at great length. And we believe that there should be further research into Flann O'Brien's molecule theory. He's going to outline that shortly, the Ann Hodges case, and the overview effect, which is another effect that's experienced only by astronauts and people that get outside of the planets into space, basically. And also research into object-oriented ontology can provide a basic foundation for better understanding of the Hodges phenomenon. And we believe that people like Sun Ra and David Bowie and the band Man or Astro Man might be musicians or creative people that have silently struggled with the Hodges effect before it became a named condition. Many of the astronauts, such as Edgar Mitchell, and cosmonauts such as Valentina Tereshkova, clearly demonstrated Hodges symptoms, and sculptor Tom Sachs undoubtedly has Hodges. It's a clear thing if you look at his work. It follows then that there may be an opportunity to safely induce Hodges into the general public and to creatively induce Hodges cases, which is where I think we're at in terms of our thinking about how to move forward, like with this Scholars Rock ready-made object. So people can meditate and think about it. Furthermore, it is theorized that the Hodges effect may result from even trace amounts of extraterrestrial materials. So smaller amounts might help with that. But it will benefit us all with a sense of curiosity, wonder, and renewed spatial awareness. As passengers on spaceship Earth, we must avoid vertigo while acknowledging our specific ever-changing position in space. And it's falling to, there's a betraying impact that the Hodges effect has on us and our extreme circumstances as passengers on spaceship Earth. Earth's equator spins 1,600 kilometers per hour. Earth's orbit around the sun is 30 kilometers per second, and the sun has orbiting spheres flying through space at 200 kilometers per second. So when we lie in bed, enjoy a picnic, or take a spin on a unicycle, we are simultaneously blasting and spinning our way through the cosmos with the vast cohort of Homo sapien and non-Homo sapien sphere-situated entities, objects, and materials. Buckminster Fuller coined the phrase spaceship Earth for this assemblage, our living conditions, and our home sphere. Hodges effect thinking allows us to dramatically update and rebrand all of this to be understood as the hurtling spherical menagerie. Spaceship Earth was useful because it placed us all in space as an idea, but as space travelers, but this is not an orderly ship or controlled voyage that we're on at the moment. This is an early piece I did before I started working on the Hodges effect, which was a cosmic disaster gallery that was a fantasy gallery that I could build and that to be struck in the path of a meteorite, so viewers in the gallery space could safely observe this strike occurring. Of course, it's an impossibility. And some of this interest comes out of my interest in art museum dust, because dust is something that's combined with viewers, the public, the art, and the architecture. And the idea of ready-made and additive and reductive sculpture plays a huge part in my understanding of art museum dust as it exists within the context of art spaces. It's an unwanted presence, but it's a very beautiful thing. And Connie has helped design, Connie Hwang has helped design these pieces that people can actually wear the dust. If they don't want to buy the photographs, we can actually have pins that people can wear, so you can wear the best aesthetic dust. Dust falls on Earth constantly. The Earth grows fatter every day under a continuous microscopic flurry of space specks. On average, every square yard of the planet should nonetheless see one speck a day, according to Hannah Holmes in her book, The Secret Life of Dust. So if you stand in a place outside for an extended period of time, odds are that you'll have space dust impact you in some way. If one wishes to generate one's own Hodge effect experience and you don't have time to be 24 hours lying on your lawn to get a piece of space dust, By placing a high-powered magnet in a downspout of a building, and with the help of some rain, one can over time collect micrometeorites, and thus, at the time of one's choosing, have a Hodges-style encounter. And you don't have to be a heroic astronaut or scientist like Kalpana Chawla or Katherine Johnson to have this direct connection to space. I'm just going to skip ahead because these are a number of things I've designed so that people can induce the Hodges effect or have their own Hodges experience through music and sound. These are cosmic event balls that are filled with space dust. You can sprinkle space dust on this specially made musical score to create music, or there's handheld different things that you can do to have Hodges experience hand exercises to have different experiences with the Hodges effect and different meteorites. And so this is kind of, I'm coming to a close. This is, let's make November 30th International Ann Hodges Day with a letter writing campaign. Here's the contact people. We'll be distributing this, the people to contact, and if you can do a screenshot, this is who to send your information to try to create a November 30th Ann Hodges Day. And I just end with, this is me as a kid when I was getting infected with Hodges in Huntsville, Alabama. With my dad who worked for Northrop and Boeing and all that. And I think this is where it started for me, but the art museum dust collecting hasn't helped my case any. So thank you.
Thank you very much, Sean, for that whistle-stop tour of your practice. And maybe you could stop sharing your screen now, please. Thank you. And so now it gives me great pleasure to introduce our second speaker this evening. It's Dr. Sean Taylor, lecturer, Limerick School of Art and Design. Sean was awarded an MA in Fine Art from the University of Ulster in Belfast, and he also completed a deep listening certificate program with American contemporary music composer Pauline Oliveros at the Deep Listening Institute, Kingston, New York. And he has most recently completed a PhD at Limerick Institute of Technology School of Art and Design in 2019. Sean has exhibited extensively internationally, and he co-established the Art and Science Collaboration Soft Day with software engineer Michael Fernstrom. He is currently the program joint leader MA in social practice and the creative environment in Limerick School of Art and Design. And I hand over to you now, Sean.
Thank you very much. And good evening, everybody. I've made a special effort for my American friends to dress up accordingly. To introduce a note of gravitas to the evening. As you can see, I am accompanied this evening by a replica of the Ann Hodges meteorite that fell upon her all those many years ago. And we have been getting to know each other since it was shipped to me from Florida. And I like to think that we have quite a special relationship now, myself and this meteorite. I'll share a screen. I'm going to show you some slides in no particular random order, which is going to make it interesting. And I have prepared a little bit of text for you all, for your delectations. So I should say that the Hodges effect has been at play here in Ireland for quite a long time, particularly with the literary giants of Ireland. I mean, James Joyce in particular probably would be one of them. And also Flann O'Brien, who you might not be familiar with, but Flann O'Brien, while under the influences of Hodges, wrote this wonderful book called The Third Policeman. And in The Third Policeman, he kind of gave very strong clues as to the origins of the Hodges effect, and he developed this molecule theory. So if you indulge me for a moment, I am going to, in the style of Flann O'Brien, try to explain the effect of the Hodges on people. So the brother asked me the other day, "Do you ever hear tell of the Hodges effect?" "Not at all," says I. He leaned his mouth confidently over to my ear. "Would it surprise you to be told that the Hodges effect is at work here in this parish?" "It would indeed," says I. "It's an incredible contagion," he continued. "Half of the planet are suffering from it. It's worse than the COVID." "The Hodges effect," I replied. "I never heard tell of that. Is that one of them exotic foreign afflictions like galloping Trumpism?" "What does it cause?" says I. "Apparently, at its worst, the Hodges effect is known to contribute to angst, mental disorientation, and nausea in your average Joe soap. I've even heard that some arty friends of mine that it can cause bouts of over-conceptualization when talking about creativity. Apparently, this is true. That's shocking, says I. On the other hand, I've also been informed that in many cases, the after effects of Hodges seem to imbue individuals with a greater sense of spatial awareness, an increased sense of interconnectedness with the cosmos, and a more complex and informed understanding of the material world, says he. How about that, says I? Do you ever hear of Ann Hodges, says he? Can't say the name rings a bell, says I. Well, they named the affliction of the mind after her, says he. Go away. And would that be the Hodges Effect, says I? No shit, Sherlock, says he. Ann Hodges is an example of a human being that is almost destroyed from the principles of the Hodges Effect. Would it astonish you to hear that she is nearly half a meteorite, says he? It would surprise me unconditionally, says I. Ann Hodges is over 50 years of age by plain computation, and she has spent no less than 18 of those years getting over being poleaxed by a meteorite from outer space that crashed through her bedroom roof and almost decapitated the poor woman. I've seen photographs of her, and she's always looking nervously up into the skies towards a particular destination or other at every hour of the night and day. If it wasn't that her meteorite was in litigation for so long, she would be sure to be more than halfway now. Halfway to where exactly, says I? Halfway to being a meteorite itself. Your words, I said, is surely the handiwork of over-conceptualization, because not one word of this can I get my head around, says I gleefully. Very funny, says he. Did you ever study atomics when you were a kid, he says. No, never, says I. This is a very serious speculation. But all the same, I will tell you the size of it. Everything in the universe is composed of small particles of itself. And they are flying around in concentric circles and arcs and segments and innumerable other geometric figures too numerous to mention collectively, never standing still or resting, but spinning away and darting hither and thither and back again, all the time on the go. These pint-sized gentlemen, don't you know, are called atoms. Do you follow me intelligently? Yes, says I, shaking my head. Atoms are lively. They're as lively as 20 river dancers doing a jig on top of a biscuit tin. Atomics is a very intricate theorem and can be worked out with algebra, but you'd want to make it and take it by degrees, because you might spend the whole night proving a bit of it with rulers and cosines and similar other instruments, and then at the wind-up, not believe what you had proved at all. If that happened, you'd have to go back over till you got a place where you could believe your own facts and figures, and then go on again from that particular place till you had the whole thing properly believed and not have bits of it half-baked or a doubt in your head hurting you, like when you lose the stud of your shirt in the bed. Very true, says I. Do you happen to know what takes place when you strike a bar of iron with a good coal hammer or with a blunt instrument? What, says I? When the wallop falls, the atomics are bashed away down to the bottom of the bar and compressed and crowded there like eggs under a good clucking hen. After a while, in the course of time, they swim around and they get back at least to where they were. But if you keep hitting the bar long enough and hard enough, they do not get a chance to do this. And what happens then, do you think? This is a hard question, I says. Enlighten me. Some of the atoms of the bar will go into the hammer and the other half into the table or the stone or the particular article that is underneath the bottom of the bar. Well, that seems logical, I agree. The gross and net result of it is that people who spend most of their national lives getting hit by tiny particles of space dust, or in the case of our good woman, Ann Hodges, by a great lump of a meteorite, eventually they get their personalities mixed up with the personalities of the moon rock or space dust as a result of the interchanging of the atoms of each of them. And you will be surprised at the number of people in these here parts who are nearly half people and half meteorites. Get out of here, I says, and I let go a gasp of astonishment that made it sound like an air like a bad puncture. And you would be flabbergasted at the number of meteorites that are half human, half partaken of humanity. Are you certain about the humanity of the meteorite? Is said of him. Is the atomic theory as dangerous as you say? It is between twice and 3 times as dangerous as it might be. Early in the morning, I often think maybe it's 4 times. And what is more, if you lived here for a few days and gave full play to your observations and inspection, you would know for certain the sureness of certainty. In her pictures, Ann Hodges does not look like a meteorite, I said. She has no appearance of an extraterrestrial and does not resemble a space rock. Ah, come on. You cannot expect her to grow antennae out of her head, but I have seen her do more incredible things than that. Do you ever notice the queer behavior of the meteorites in these parts? I'm not long in this parish, says I. Then what's the meteorite in space does if you think it is pleasant to be surprised continuously? When a man lets things go so far that they are half or more than half a meteorite, you not see so much because they spend a lot of their time lying quietly on the ground or in their beds. Of course, there are other things connected with the Hodges effect that I will mention to you separately some other time. But a woman-charged meteorite is a phenomena of great charm, empathy, and intensity, and a very interesting article. See that Ann Hodges? If I was a betting man, I'd put her percentage of meteorite as close to 49%. She's 49% meteorite, says I incredulously. Yes, says he. Does that mean that her meteorite is also 49% Ann Hodges? It does, says he. Jesus, says I. And what way do these people's meteorites behave, says I? I mean, these meteorites people, or whatever is the proper name for them, do I need the assistance of pronouns here? The behavior of a meteorite that has a high content of humanity is very cunning and entirely remarkable. You never see them moving by themselves, but you meet them in the least accountable places unexpectedly. Do you ever see a meteorite resting in the downpipe or the gutter of a roof or your home, or sitting quietly on a shelf of a warm room when it's lashing down with rain outside? No, says I. And what would they be doing that for? Listening, says he. Listening to what, says I? Ah, no, says he. That would be a different story altogether. And there you go, folks. That's the end of my story. So, if you want to get involved in this most amazing journey of ours, there are two ways you can sign up. One is to sign the Uplift petition, which we are circulating, which is also on the link here tonight. And the other, of course, as Sean already mentioned, is to write directly to Simonetta Pippo, who is the United Nations Officer for Outer Space Affairs, probably a long-term Hodges sufferer. So remember, there are skeptics out there, but don't be put off by their rambunctious behaviors. Even in this country, where we live right now, we have people who are very, very skeptical and who do not wish to be affected by Hodges. And that, my dear folks, is the end of the story. Thank you very much.
Thank you for that, Sean. Lots to think about there. But it's now time to introduce our next presenter. And it is our great pleasure to welcome Connie Hwang, Professor of Design, San Jose State University. Connie is the principal of Connie Hwang Design in San Francisco, California, and in her work, she places great value and sensibility on the pursuit of creative excellence. Her studio specializes in museums, galleries, cultural sector, and restaurants, and has received numerous awards, including the American Alliance of Museums publications. Connie is a professor at San Jose State University. Welcome, Connie.
Thank you, Valerie, for the intro. I have 5 minutes to talk about my involvement with the project. So I'm going to start sharing my screen here. When Sean Miller first came to me with this idea of how would I communicate this meteorite Hodges effect with everyone else in the world. So he showed me tons of photos and things he's thinking about. And I think as a designer, my position here and there has always been, how would I take all these materials using what I have learned from school, from past, from future even, and how do I visualize them in a way that can relate to everyone else that's passing by. So the first thing you see right here is the oops, can you guys see it? Okay, let me go. First thing you see right here is this is 120 inches, 60 inches billboards. It's quite large. And we decided to find the color green to represent something that's glow in the dark. And we also incorporate QR codes so people can lead to the website to really find out more about Hodges Effect. So I'm going to run through several sets of the design. So a lot of people will say, if I just take the beautiful artwork that's done by Sean Miller, and how would I share with people? So I throw in some icon here that can relate to people to understand this billboard actually has to do with Space Week. And these billboards are around Cork, Ireland right now. So you will see them around the city, everywhere. Okay, so here are the 5. The next thing I would like to share with you . So the other thing that we're working on with Valerie at the National Sculpture Factory is creating a zine that can be telling the story about Ann Hodges, as well as the idea that coming from Sean Miller and Sean Taylor here. The zine is going to be 5.5 by 8.5 inches. And of course, using the glow in the dark green with beautiful black to share with you guys here. So the cover actually, we live some of the imagery coming from the day that hit Ann Hodges' house. So you guys can tell we use this particular typeface to kind of not only share with the idea of space, but also to tell people that this project is done in 2021 and has this modern look to it. So I placed this rock exactly 5 by 5 by 7 inches in this zine. Of course, on your screen, this is probably look really huge right now, but it is 5 by 5 by 7 inches and its weight about 8.5 pounds. So again, right here is taking the beautiful artwork drawn and created by Sean, and how do you combine the news and the writing to tell a complete story with everyone. This is the last slide that I will share with everybody. So again, yeah, the symbol from our planet. So just have fun, enjoy, and take away whatever is have around you. So this is what I have to share. I'm super happy to be here. I'm going to end my presentation right here. Thank you.
Thank you very much, Connie. We are really looking forward to seeing that zine when it is ready, and we might come back to that at the end around timelines. But now it is my pleasure to introduce Jade Dellinger, the gallery director of the Bob Rauschenberg Gallery in Florida Southwestern State College. Jade is the director of exhibitions and collections at Florida Southwestern State College, where he devises and delivers the exhibition program and related events at FSW's Bob Rauschenberg Gallery. Jade has collaborated on curatorial projects with major museums in the US, Europe, Mexico, and South America, and he has written for international publications including Sculpture, Flash Art, Art Papers, and has co-authored the book, Are We Not Men, We Are Devo. Jade is also the enviable owner of one of the limited edition models of the Moon Museum created by Forrest Myers, a museum that now exists on the moon and features artwork by Forrest Myers, Klaus Oderberg, Robert Rauschenberg, Andy Warhol, and others. And so we are delighted to welcome you, Jade.
Thank you so much. So I'm going to share the screen here. Sean's helping me out. It's a bit of a departure from Hodges Effect, but perhaps not. We're 1954, when Ann Hodges was struck, was rather an important year for our gallery namesake, Bob Rauschenberg, as well. And it was the year in which he sort of defied categorization, and he coined the term the combine, as his work was not about making paintings or sculpture per se, but he came up with this notion of making combines. Prior to that, he'd actually been featured in Life magazine in 1951, and so he surely had been following when the story broke about Ann Hodges. And later, as we'll talk about briefly, he had very close connections, both with astronauts and with those involved in both the Mercury and the Apollo projects, but he was a local resident here. So we are fortunate to have his name. We're a small community college, basically state college, but our gallery has a long 40+ year history. Bob, this is sort of his place nearby. My first connection to him, though, was that as a teenager, I wrote him a fan letter. My grandfather was a Baseball Hall of Famer, and so I would help him with his fan mail and read lots of creative letters that would come to him. And I realized you could reach your heroes by just writing a letter. And so I had learned that Rauschenberg was a big drinker and that he hung out at this particular English pub on Captiva Island. And I wrote a letter, care of the pub, enclosing in the letter a little PS saying, here's $10, let me buy you a drink. Much to my surprise and delight, very soon thereafter, I received a lithograph in the mail. He'd actually just returned from China, where he'd had a major exhibition, inscribed to me, and this small note that said, I'll have that drink and wish you luck just before I go to work tonight. I've put a gift in your pocket. Soon after my arrival, many, many years later here at the Rauschenberg Gallery, I was told lots of stories about Bob, but one of those things was that at dinner parties, Bob, if the conversation got boring, he would pull something out of his pocket, and he carried lots of odd objects. I've not heard for sure that he had a meteorite, but I would not be surprised if he did not, or if he did. He had an Egyptian mummy's eye that he would occasionally pull from his pocket at dinner parties. There is a tradition of this. Oh, I'm not advancing here, sorry. Entered the waiting room. We're getting some notification. Sorry, I'm trying to go to the next slide here.
Let's do stop share for a minute and then we can get it again and pick it up.
Yeah.
There you
Okay,
go.
sorry. And then can we go back?
Yeah, let's try.
Sorry about the technical glitch.
Oh.
So I can actually sort of advance without seeing things, I guess. The idea of a miniature museum is not something that is new. One of the artists that so influenced him was Marcel Duchamp. Duchamp actually did a, there we are, sorry, we're back. Marcel Duchamp did a valise that had a sort of retrospective of his work. Even our friend here, Sean Miller, made his John Erickson Museum of Art, which were miniature museum galleries, and invited many artists to collaborate with him and to make exhibitions within the context of these miniature museums. Rauschenberg, again, had this long history here in Florida and with our gallery, but his story goes, starts much earlier. He was in the mid-60s in New York, and he was an organizer in a sort of seminal art event, which was called 9 Evenings. And it was all about connecting engineers with people involved in theater and experimental music and dance and visual artists. This, interestingly, led to, after the 9 Evenings, to further collaborations. This is actually Rauschenberg working on a kind of interactive or receptive kinetic work with Billy Kluver. Kluver was actually at Bell Laboratories and became a close friend of Rauschenberg's. With Kluver and with Fred Waldauer, Rauschenberg ended up establishing, soon after 9 Evenings, Experiments in Art and Technology. And so this was a group that was all about pairing engineers with artists. He was also soon thereafter working with NASA as an official artist in residence and doing a series of images that were based on imagery that he was obtaining directly from, sorry.
It's, they're not, I don't think they're seeing the imagery.
Oh.
Just close this and select it again.
So it's not, we're not sharing the screen?
Yeah, it was, I think we were seeing it, but I don't think they were.
Okay.
Can people see that? Okay.
Yes, okay, thank you.
There you go.
Okay, so Rauschenberg was working on projects both with Experiments in Art and Technology and with NASA as artist in residence. He, in fact, was able to attend in person the launch of the Apollo 11. And in his journal, which you're seeing a page from here, he describes that as being airborne, lifting and pulling everyone's spirits with it. At the same time, Experiments in Art and Technology would casually, informally meet at Max's Kansas City, a bar in New York City, where Andy Warhol had sort of a table in the back room. The guy with his tongue out in this image is actually Forrest Frosty Myers. And while everyone was celebrating, Frosty, who made large-scale sculpture, made the point of asking the group, you know, what is it that in fact we've left behind? We've done this tremendous thing, but we've nationalistically planted our flag. We've won the space race. But aside from that, we've left detritus on the moon. Shouldn't we as artists be thinking about leaving something of our humanity and something in the form of works of art? To which immediately the engineers responded with, again, every ounce counts, Forrest, and you make these large scale sculptures. But we at Bell Laboratories had the transistor team. We developed the transistor, and we're working in microcircuitry for communications and so forth with the Apollo missions. So if everyone here or the artists or you were to make a drawing, we could reduce it to a very small chip, essentially, which seemed like a brilliant idea. And again, Frosty not wanting to make it about himself, but realizing he was in the company of other much better known artists, Frosty decided that he would create a museum and invite those around him to contribute works. And the first idea was really that the astronauts were carrying with them a personal preference pack, a kind of pocket. Everything was tested, weighed, et cetera, that would go into this pocket. They would often roll up little American flags or have tie tacks or stamps that they would bring back with them and give to friends, having been flown or having made it to the moon. The initial idea was that it would end up in that personal preference pack with the permission of NASA, but there was only a short window between Apollo 11 and Apollo 12, so they had to work quickly. They tried to get permission. They were never given permission, in fact, but they did produce the small chip, and it was produced as a multiple. So each artist was to be given one. This shows sort of the positioning of each artist's work on the chip. Again, Forrest's large-scale work became a computer drawing that you see in the lower left corner there. And the work in the middle is actually on the top is Robert Rauschenberg, just making a simple line. Andy Warhol always claimed that his was a rocket ship, and this is his quick sketch. Sometimes he would say it was an A and a W, that it was his initials. You can be the judge of that. Klaus Oldenburg did his geometric mouse, and they were actually created on one sheet, and then they were cut with a diamond saw. They were basically the size of your thumbnail. They had a kind of alternate plan. When NASA didn't agree to allow them to do this officially, they decided to do it secretly and to engage their friends at Grumman. And they sent one down. It was attached to the landing legs of the LEM 6. It was hidden in the Kapton foil, essentially on those legs. And of course, there's separation that happens. They received a telegram confirming that they were on board, all systems go, with the pseudonym John F. because of John F. Kennedy and the engineer not wanting to lose his job. So secretly, and upon the return, successful mission, the astronauts never knew that they had carried this. So I've been on a program here in the United States with Alan Bean, who with me was the first to sort of learn of their having delivered this. decades and decades ago. And I've been going around doing a kind of exhibition in my pocket, carrying with me the Moon Museum that is the one that I've managed to get from an engineer, but I have it here, I have it for the camera, but that ends sort of my talk. I do believe, again, that it's likely that Robert Rauschenberg was indeed impacted by the Hodges effect over the years too. And here's the Moon Museum. So thank you very much.
Thank you for that, Jade. That was absolutely fascinating. I love that story of the Moon Museum making an unauthorized visit to the moon. And so now it is my pleasure to introduce Dr. Niall Smith. Niall studied astrophysics, graduating with his PhD from University College Dublin. He lectured in the Department of Applied Physics and Instrumentation in Cork Institute of Technology for 18 years before becoming the Institute's first head of research in 2005. Niall is also the founder director of the internationally award-winning Blackrock Castle Observatory, which has just celebrated its 13th anniversary and over 1.2 million visitors. Niall was also on the higher education representative on the National Steering Group for the Irish government's recently published Space Strategy for Enterprise. And I also should have said earlier, this is actually a first-time collaboration between the National Sculpture Factory and Blackrock Castle Observatory, and it is a great honor that we were able to bring our two organizations together to support this brilliant project. So I'll hand over to you now, Niall.
Well, thank you very much, Valerie, and delighted to be here tonight. I'm going to keep this short and also PowerPoint free. So hopefully there won't be any technical issues other than what I have to say. It is a great pleasure for us at Blackrock Castle Observatory to be part of this particular project. And one of the things that at the observatory we strive to have as our mission is to excite, enthuse, and encourage people of all ages to get interested in the universe of which they're part. We often think of a phrase by a real hero of mine, Carl Sagan, which is that we are the universe becoming conscious of itself. So most of the universe that we sit in, as far as we can tell, has no idea that it exists, but we do. So we have this really privileged position in the universe. And when we interact with it, one of the things that got us really interested when the two Seans came up with the concept of the Ann Hodges effect was that meteorites, dust, collisions in the universe have played a key role in us becoming sentient beings. So it seemed totally realistic that we should become involved in a project that got us as sentient beings thinking about our place in the universe through the means of collisions. And the unfortunate Ann Hodges, who was maybe subject to an over collision when perhaps in hindsight she would have preferred not to have been. Just to give you from, I suppose, a Blackrock Castle perspective, why we think this is so exciting, and the idea of an Ann Hodges Meteorite Day ultimately as one of the outcomes of many of this particular project. If we go back about 5 billion years ago, we're effectively all a cloud of gas and dust that's rotating pretty randomly, pretty uninterestingly in a part of a galaxy which itself is pretty random and uninteresting in a very large universe. But gravity starts to cause this particular cloud of gas and dust to swirl, and gravity doesn't do anything really interesting with that cloud of gas and dust. But what really happens of interest with it is when you start to get collisions between microscopic particles. The gravity isn't enough to cause these particles to stick together, but the collisions are. And so those collisions build up larger pieces of dust, which collide and generate larger pieces of dust, until eventually you start to get something that starts to look like a planetoid. And that gravity from the planetoid then starts to attract more and more dust in until you get something like the early Earth. The early Earth was a horrendous place to be. It was super hot. We call it the Hadean Earth. And it was utterly inhospitable to life. There was no possibility of life as we know it existing here. So we have to think then, well, what happened to that Earth? And that Earth, because it was so hot, was completely devoid of water, actually devoid pretty much of oxygen as well. We know now that that oxygen and that water was returned to the Earth by collisions from comets and asteroids, and actually mostly from asteroids that carried water with them, brought it to the Earth. In the early days, the Earth was so hot that it vaporized and went away, but eventually all that water caused cooling. And once you got cooling of the Earth, you started to get the possibility of water. And one thing that we all need for life is water. You can have life without oxygen. You can't have life as we know it without water. So collisions were absolutely crucial to the formation of our planet. In fact, some of you might know that the moon that we can see tonight if we look outside, the moon was the result of a collision between an object roughly the size of Mars and the Earth early on. And the moon now, because of its tides, has a massive effect on the way that life on Earth evolves, and actually a massive effect on the way life on Earth behaves even today. That's maybe for another discussion. So that collision of the moon and the way that the Moon-Earth system exists today continues to affect who we are, even after all that fundamental collisions that bring the water and other good things to the Earth that allow you and me to exist. So when we think about collisions in the universe, even on this very sort of parochial level, it has been absolutely a set of fundamental phenomena in the universe which allowed us to come into being. And then you get to this exciting type of collaboration between artists and scientists. What I find really interesting about it is I don't think like everybody else in this team. And I find that really interesting because it forces me and my colleagues and people I know to think differently. So we're linked by collisions, by being able to think, but we're also separated by that differences of approach in thinking, allowing us to look at the universe of which we are now have become conscious in different ways. And going forward, if we think about sort of the ultimate fate of the universe or the ultimate fate of the planet, well, for those of us maybe in Cork where it's coming close to bedtime in a little while, maybe you want to not listen now in a sense, because probably the ultimate fate of the Earth is twofold. One, we're either going to be swallowed up and burnt by the sun, or we're going to be hit by something really much larger than what Ann Hodges was. And NASA have a wonderful phrase for this. They call it an Earth sterilizing impact. And I don't think that needs any explanation. It is what it says on the tin. Unlike things like volcanoes, or even, if I'm allowed to use the word, pandemic, which are really just not going to kill everything on the Earth. A collision with an object big enough has the potential to do that. So when we look out into space, when we think of how it's brought us to where we are through collisions in the past, we also need to realize that in the dark is lurking the possibility of ending all that we have put together in the future. However, if you are about to put your head under the pillows in Cork and decide that this is too depressing a way to finish your day, there is, of course, a good end to that part of the collision story. And it's this: because we're sentient, because we have developed technologies, we are, for the first time in 4.5 billion years, at a position where we can launch spacecraft that can deflect these asteroids, these comets, these things lurking in the dark that might be injurious on a major scale to us. So collisions are fundamental, but we've got to a kind of a stage where we can type of control them. So the Ann Hodges effect gets us all to think about, one last thing, when Sean Taylor and Sean Miller were talking about the percentages of Ann Taylor that was a meteorite or whatever, if you think in many ways, the Earth is only here because of collision. So all of the material in you and me, in a sense, is Ann Hodges fundamentally at its core, because without the collisions, none of this actually exists. So it's been fantastic so far to be part of this program. We're really enjoying the possibility of seeing where this goes into the future, and delighted to have a few minutes to share some thoughts from the Blackrock Castle Observatory side of the house with this project. And with that, I'll hand you back to Valerie.
Thank you, Sean, or Niall. I don't know whether I should be excited or terrified by that, by that little synopsis. But that brings us to our final presenter this evening. And last but by no means least, we welcome Dr. Julia Cartwright, Assistant Professor of Geology in the University of Alabama. Julia Cartwright is an Assistant Professor in the Department of Geological Sciences, University of Alabama. She is a planetary scientist who studies meteorites to better understand the formation and evolution of the solar system. Her research approach is to use multiple techniques to characterize extraterrestrial materials, either in terms of composition or in terms of chronology. Julia studied for her undergraduate and graduate degrees in the UK at Oxford and Manchester universities, and she has held postdoctoral positions in both Germany at the Max Planck Institute for Chemistry and in the USA, where she carried out research at Caltech before joining the University of Alabama faculty. And we're absolutely delighted to welcome you here today, Julia. Thank you.
I'm absolutely delighted to be here. Thank you so much for having me. I'm going to get up from my chair and adjust my camera, so apologies for that. Hi, everyone. I've just come from teaching planetary science, so I'm feeling fairly revved up to be chatting to you about it. So Valerie, thanks so much for that kind introduction. As you stated, I play with meteorites. I guess that's what I do all day, almost all day. A few other things tied in there as well. But yeah, so I study samples that come from outer space, and they don't land in my lab, but they're recovered, and I'm able to request materials, or I'm able to purchase materials, and I'm able to try and understand our solar system by looking at these really fabulous samples. So I've got quite a lot of different materials in the collection. Today I was actually able to get the real Hodges meteorite on loan. So I'm just going to disappear off screen for a sec and pick this up. So here we go. I still like yell every time I pick this thing up. So here we go. This is it, guys. This is the real Hodges meteorite. I gave it a bit of a weigh earlier today, and it's about 4 bags of sugar, so about 3.8 kilograms. So it's a fairly hefty, like this would do some, I mean, I'm not very strong, so you can probably see me bouncing under the weight of this thing. So you can probably get an idea as to the type of damage this would have done by landing on Mrs. Hodges. This meteorite is actually, its real name is Silicorga. So it's a fairly bit of a mouthful, but it's named after the small town that it was discovered in, as with all meteorites. So meteorites typically are named after where they're found, and in this case, that was Silicorga. So it's kind of known affectionately as the Hodges meteorite because it managed to do some damage to Mrs. Hodges, but it is called Silicorga. Generally speaking, this is one of the biggest samples that I typically deal with on a regular basis. It's pretty hefty. It's called an ordinary chondrite, which means that it has a classification based on its composition, and as a chondrite, it means that it retains information from the very beginning of our solar system. So this meteorite contains these really amazing phases called chondrules, and these chondrules are round, spherical-like objects that effectively represent snapshots of time as our solar system was cooling down, and these things started to condense from the nebula and become incorporated into a planetary body. So it's, I don't know, I think it's pretty fantastic that this rock that I'm holding contains information about phases that formed 4.56 billion years ago. I just think that's just, I don't know, it's kind of mind-blowing stuff. I also have a thin section of this meteorite on my microscope behind me. So I can pull up that screen and just give you guys a little bit of a tour. So you can get like a couple of minutes in the life of me for a day, if that floats your boat. So if you just give me a second to do so, I'll take the microphone with me. And you'll see the back of my head for a little bit. Let me see, share screen, this one. All right, so just to give you guys some context, hopefully you can see that. I think hopefully Valerie's nodding, excellent. So when it comes to trying to look at samples, I'm talking to you as if you're there, you're over here. In terms of trying to look at samples, geologists take a rock and they slice it very thinly, thin enough that you can actually shine a light through it. And then that gives you a lot more freedom to be able to investigate different phases that might be present. So what we've got here is a thin section of that meteorite that's been mounted on some glass. And what I'm doing is I'm shining light through it. So already we can see a fairly slightly overexposed image. Let me just move that a little bit. There we go. So what I'm able to do is I'm able to move around and kind of discover different parts of the solar system by just moving my microscope, which is kind of amazing. So I mentioned that you can get these round phases that form the little chondrules, and you can see a couple of really nice examples of those. I don't know if you can see my mouse, but I'm just circling one of them right here. And this kind of looks really, really, it's just a super exciting type of rock. Now things get a little bit more kind of disco if I add a filter to my microscope. So another really useful tool in any sort of microscopy is we're able to kind of manipulate the way that light behaves as it's entering a sample. So by adding this filter, what I'm doing is I'm effectively slowing the light down, and light is affecting, or is being affected in different ways depending on the chemistry of the mineral that I'm looking at. So what this can really do for me is it can really start to highlight some of those really, really interesting features. Each of these different chondrules formed at different or under different circumstances. And what you can do as a geochemist or as a petrologist that focuses on meteorites is you can try and assess exactly when those were. So some of these textures are, so this is more of a porphyritic texture, these different fragments of things coming in there. There's a couple of radial, so that's got a more of a radial, like it's been, look at, you're over here, as if it's been nucleated from a point and then moved around. That's what we're seeing in some of these images. Each of these chondrules probably represents a different snapshot of a process happening in the solar nebula, and they've all been glommed together in this meteorite for someone like me to look at. So that's kind of what I'm looking at, and for me, my microscope is a very, very important tool. It gives me a lot of information about things that I'm trying to understand, and it's by studying these meteorites that I can try from my laboratory, try to understand these different processes that are happening in our solar system. And meteorites can tell us a huge amount about the Earth. We're fairly aware that our Earth is a little bit different from something like an asteroid. Most asteroids have not necessarily been through the kind of planet forming processes that you might expect planets to have gone through. Planets have these kind of stratigraphic layers that have formed. So if you remember back to geography or geology at school, you'll probably remember, or through studies, you'll probably remember that we've got these different layers in the Earth. We have the core, we have the mantle, and we have the crust. And those materials that formed our planet probably had initial compositions that were the same as this chondrite. So they had chondritic compositions, very similar to the Silicorga meteorite, to the Hodges meteorite. And they've been through these massive planet forming events, and everything is recrystallized out. And what we end up getting is these wonderful specimens that show different processes and look totally different to anything that we see on the surface of the Earth. I've got a couple here that I'd like to just show you, so it can give you a bit of an idea as to the breadth of the different things that we're seeing. So I'm just grabbing a calcite meteorite here. So these sorts of meteorites, we think, I'm going to hold up to the camera, it probably won't autofocus, but you can kind of see this pretty funky looking meteorite. It's iron rich, and it has some really wonderful silicates in it. So when our planet goes through a differentiation process, this massive melting, we start to get separation of things. So all the heavy stuff goes to the center of our planet, and then the lighter stuff starts to be kind of accreted or created in those outer layers. So what we have here, this meteorite, we think actually represents a material that comes from the core mantle boundary of something like a planet. So we have this wonderful metal or metallic phases, and we have these wonderful silica crystals around the outside. So these are really, really fantastic specimens. As you go a little bit further out, you start to see things that are a little bit more similar, to what you might just see like a normal rock. So in some senses, some of the rocks that I study look a little bit like cement or concrete because they represent fragments of material that come from the surfaces of pulverized planetary bodies. So you might see this rock in the street and just give it a kick and not realize that you're dealing with a meteorite, which is kind of fun. And then we can also look at a few other things as well. Here's a chunk of the moon. I know Niall was talking about that. So we have some, this is a little fragment of the moon with a few different phases in it. It's not brilliantly well structured, but we have these different materials which tell us that we've got a brecciated rock. This has come from the surface of our moon. So there's a bit of a breadth of things to be studied in the land of meteorites, and it's a quite a joyful place to be. But one of the other important aspects, which is why I'm really excited about this arts work and collaboration, is that I look at things from the perspective of a scientist. I'm looking at these things as samples that I am trying to determine big things about the solar system, but they are very beautiful in of themselves. These are pieces of art, and I'm involved in a couple of collaborations with different artists to try and better understand those things and to help me better interpret what it is I'm looking at. So I find that quite a fascinating aspect to that too. So I won't mention destruction and things like that in our solar system, but Niall's definitely correct. This is definitely something that happens, and it's one of the reasons why we have these wonderful samples to look at today. Collisions in our solar system have allowed these meteorite fragments to be on Earth colliding trajectories, and we've been able to intercept them and study them in our lab. So I think I could talk to you guys for hours on this, so I think I might just stop there and hand back to Valerie. Thank you.
Thank you, Julia. I wish we did have hours for you to continue talking to us about this. You and Niall could counterbalance each other out there. So I think what we're going to do next is we will invite the two Seans, Sean Taylor, Sean Miller, to come back just to give us some closing remarks about what is next for the project and what we can expect to see. And we might have a reference to the zine at that point. I'm not sure. Connie might come back in then as well. So I'll invite you both back to close out the event.
Thanks, Valerie. Just to briefly mention that tomorrow, for those people in Cork, I shall be driving from my house here with this replica of the Hodges meteorite. I don't think I can pronounce the correct name of the meteorite, but I shall be driving it around Cork City in my car tomorrow and imbuing the city with what I hope is the essence of the Hodges effect. And then at roughly about 1:15 p.m. tomorrow, I shall be taking the meteorite and causing a collision between the meteorite and the walls of the National Sculpture Factory in Cork, and thus releasing, I hope, the meteorite dust inside and kickstarting the Hodges effect for the people of Cork. I'm really looking forward to this. And before I wrap up and pass on to Sean, I would like to say that, you know, between now and the 30th of November, we all have an opportunity to put some pressure on the UN to try and raise the awareness of a potential international day for Ann Hodges, who really does need to be celebrated. And so I would encourage you to look at the links that are on the event page. Follow those. You can sign the petition using the Uplift link and then share it on, or you can write directly to the United Nations in Austria. But I'm also aware that tonight well, not tonight here, but possibly not tonight there, in the Rauschenberg Gallery, Sean Miller is going to collide his replica in the gallery for us. And so, Sean, would you like to say a few words before you do that? Seems that Sean is gone. It's the Hodges effect.
It's the Hodges effect. We've lost Sean Miller momentarily, perhaps. He might rejoin us, but Sean Taylor, I might bring Connie back in here at this point just to give us a quick update on the zine that Connie talked about, which is also something we're very excited about seeing the launch of that. And I'm just wondering, Connie, do we have a timeline? Or are you still working on that? Do we know when we might have that?
Yeah, thank you, Valerie. So we're working on this, a 24-page zine, and I'm supposed to release the files to a printer in Ireland. And so it will be made in Ireland, and it will be available for people to view at your National Sculpture Factory. So on the 30th, actually, November 30th, it will be launched.
Brilliant, Connie. That's wonderful. And of course, we will share information with people and we'll collaborate with Blackrock Castle Observatory about how, if you are interested in how you can get your hands on one of these incredible zines, which we're very excited to see. Just having seen some of the pages that you shared with us there earlier this evening, it's super exciting. So what I might do is if Sean Miller joins back in, we can hand over for the final words from Sean, but we do have some really interesting questions that have come through, and I'm conscious of time, so I might put some of those through to the panel and just see what comes of these. So the first question is from Katie from Clare, and Katie asks the panel in general, do you get paranoid about being struck by meteorites considering how much time you spend focusing on the Hodges effect? So I think that perhaps is one for Sean Taylor to start off with.
I'm not sure because I've been hit so many times when I'm drunk.
Brilliant. Well, we know Niall Smith might want to come in on this and say, do you get paranoid about being struck by meteorites, Niall?
No. In short, it might sound really bad. I wouldn't mind being struck a little bit by a meteorite. I mean, in one sense, we're all kind of struck by them all the time because they're kind of floating around in the atmosphere. So it's a very low velocity collision. In fact, you know, if you go for a walk tonight, you're likely to end up with some, well, likely, there's a probability you'll end up with some microscopic meteorite dust in your hair. So it's in that sense, no, not worried, kind of celebrate it, if truth be known.
Brilliant, thank you. Adam from Kilkenny asks, will it still count as the Hodges effect if we manage to land an astronaut on a meteorite? I don't even know if that's possible. As somebody more informed on these things than me will have to answer this one.
I'd pay good money to see that. How are you going to do that? You know, well, we could probably call that reverse Hodges effect.
Yeah, reverse Hodges effect, indeed. And then we have Aidan from Cork who asks, do we feel we should be more grateful for the destructive impact of space rocks, given that the annihilation of dinosaurs is what allowed mammals such as ourselves to step up and thrive?
Yeah, well, Julia might actually want to say something, but my short answer would be yes, but Julia, you might want to say a few words on that.
Yeah, I mean, I'm grateful because I get to study this stuff all the time, right? So, I mean, I guess so. These massive impacts were happening throughout our solar system. So yes, you're right. The dinosaurs were, we think, mostly wiped out by this very, very large impact that happened about 65 million years ago. There's actually a much more significant extinction event that happened many, many years before then that wiped out something like 90% of the biota of life at that point. So that was pretty drastic. So we do, I mean, we have a lot to thank physics for, I guess. So I'm going to say yes. I think my answer is a yes.
Brilliant. Anybody else want to come in on that from the panel? No, you're all shaking
their heads. Yeah, I think, you know, every cloud and all of that, and yeah, we're probably glad that the dinosaurs were probably moved left of stage 65 million years ago. They might have been anyway, but that probably accelerated the process. So yeah, but I guess, you know, that's enough big collisions. Thanks very much. Let's not have any more for some period of time, perhaps.
Brilliant. We had another question that was directed at Sean Miller and some references that he made during his talk, but Sean's Wi-Fi has actually just cut out on him. We've just had an update, so we may not be able to put that question to Sean. It was specifically around object-oriented ontology. So Sean Taylor, I don't know if you want to come in if I put out the question, or otherwise we can put it to Sean Miller and maybe get an update that we can share afterwards. But the question was actually, I'll just read it here. Loving all the wonderful presentations. Sean mentions Graham Harman's object-oriented ontology, OOO, in relation to researching the Hodges effect. My question is, how does object-oriented ontology inform this research, and Or does Sean think that there is a place for metaphor in the astronomical research that is traditionally perceived as more of an academic and empirical area of science? Thank you.
Ooh, that's a doozer. I'm gonna leave that one for Sean.
I suspected you might. I think I will be leaving that one for Sean too. But certainly we can put that question to Sean and we can get the answer and we can share that maybe on our social media. Sean Taylor, one final question from me to you in relation to the throwing of the meteorite cast tomorrow. How will people be able to see this? Will you be sharing it? Is there a website? How will people be able to kind of keep up to date?
I shall be documenting it. We'll be recording it, and also there will be some photographic documentation of it as well. And we will put that up on. It'll find its way up on the website, and I'll probably share it on social media platforms as well.
Brilliant. And you mentioned that the project will continue until November 30th, and it will be an ongoing kind of as part of research for you and Sean Miller. Is there anything you want to share with us about future events that we can look forward to?
No, not really, because we're keeping some of those under wraps. But I mean, I think, you know, in all of this, let's not lose sight of the human story. You know, Ann Hodges, and for those who are listening in tonight who have not read about her story, her rather unfortunate story, since she was introduced to the meteorite, it is quite an amazing story, and it's a story that needs to be, you know, told again and again and again. And I think, to me, someone like Ann Hodges is one of the many unsung heroes of this world. And I think it would be fitting if we were to create a day for her, or a day in her honor, which also, you know, sort of acknowledges the fact that we are one bump away and one collision away from, as Niall would put it, a terminal sort of cancelling. But I think it's a wonderful opportunity between now and the 30th to really try and see if we can make this happen. For both Sean and myself, this would be quite an amazing opportunity, and would be a fantastic outcome of this project. And there will be other manifestations. But you'll just have to keep watching the website for updates. So I do believe Sean Miller is back with us finally, after a Hodges-induced blackout. Sean, do you want to?
It was a new one, and it just came from out of nowhere and took us out all at once. But we're back.
Great, good to see you.
Are we still talking to people?
We are, Sean. We were just doing the final wrap up, Sean Taylor. I know that you were coming back to do a little final summation of the project, and we've had a couple of questions from the audience already. Yeah. But I mean, if you'd like to say any final words.
No, ask him the question first.
I can ask you the question. We had a question that was specifically for you, Sean. I'm just going to find it here now. So it says, Sean mentions Graham Harman's object-oriented ontology, OOO, in relation to researching the Hodges effect. My question is, how does object-oriented ontology inform this research, and/or does Sean think that there is a place for metaphor in astronomical research that is traditionally perceived as more of an academic and empirical area of science?
I think there's room for it in terms of the dialogue that can go on, kind of going back to what Niall was talking about between science and art. A lot of the times I think that metaphor, when it's used between artists and scientists or in a creative way during a research situation, can make really exciting things happen. And you don't always know what to do with it. But I think even just creativity existing in the planning of something, like when you're brainstorming or coming up with something, the ability to really have a lot of ideas creatively bouncing around can often help develop new strategies that you hadn't thought of if you're being very empirical about it. And object-oriented ontology, I mentioned it in terms of Timothy Morton, and I think that Timothy Morton's work, in terms of thinking about interobjectivity, like the fact that, you know, this isn't the Hodges meteorite, but this is the force of the Hodges meteorite coming through to this exact moment. So the interobjectivity, I think, helps us understand non-human things as having their own agency, the agency of tiny scraps of metal. And I'm just gonna like really quickly run away and drop this meteorite on a radio in honor of Ann Hodges from this lift, and then I'm done. Three, two, one. So write a letter to the UN and stop by and see, if you're in Ireland, stop by and see Sean touring his interobjective ongoing on Hodges meteor strike. And hopefully everybody gets a little bit of Hodges, just the right amount.
Thank you very much. And I think that is the perfect moment to wrap up this evening's event, today's event for our international guests. And it is just falls on me now to thank each and every one of our presenters today. So that's Sean Miller, Sean Taylor, Connie Hwang, Dr. Julia Cartwright, Jade Dellinger, and Dr. Niall Smith. And it has been our pleasure and our honor to have you all here, and all of you as audience members for joining us for this event. So to keep informed of what is coming next and what's happening for the rest of this week and what will be happening in the future iterations of the project, you can keep checking on the National Sculpture Factory's social media, so our Instagram, our Facebook, and our website, and also I think on Blackrock Castle Observatory's website as well. We'll be updating events as they happen. And thank you very much.
Thank you so much.
Thank you. Right.